Okay, I thought I'd record this video this morning just to help you understand what I'm going to ask of you. WebSign does great. It doesn't. It kind of allows you to skip steps. And when on the exam, this last exam, I'm going to ask you to do it this way. Okay. So the first thing you've got to do, and this is from those cookbook problems that I have posted in week 10, right up at overview. And you could have posted this one as a attendance post, of course. Now that I'm doing it, it's claimed. But you could go do another one. There's a few other ones in this, and then there's a few other ones in the proportion side. What you got to do to make sure when you run these significance tests or even a confidence interval that the sample's meeting certain conditions. Okay, well, one of them is that it's random, and so let's see. This is about batteries. What do we do? Blah blah blah. They say the mean life of the best battery is 54 months, with a population standard deviation of 6. So do you see that? That's what they claim. They went out and did a sample of 50 batteries, so that's N. And suggested to determine the life, they found that 50 batteries have a mean life of 52, so X bar equals 52. That's the sample mean. And it also gave us the sample standard deviation of 6 months. Notice that's the same as the population standard deviation. That's just a freak occurrence. Honestly, we don't need to worry about this, about the sample standard deviation, so we know the population standard deviation. Now, the condition. So what I just did is I noticed, oh, it's about means, not about proportions, a quantitative variable. They also told me that I've got a population standard deviation. Now, they don't tell me anything about whether or not the parent population is normal, but I've got a sample of bigger than 35. Remember, if n is bigger than 35 or bigger than 30, it is. So that if it's bigger than 30, the central limit theorem holds. So I checked for randomness. I checked for what kind of variable it is. I checked for the condition for that kind of variable. That's where n equals 30 or more than 30. So we're good to go because we know the population standard deviation. We're going to run a z-test. Rossman chants that slick calculator at bench point, it doesn't do z-test, it does t-test. Honestly, these calculators that do it, they always feel clunky to me. I think it's almost easier to do this by hand. So then we got to state the claim. So what's the claim? The claim is that here's the claim right here. Here, can I go? Can I go with a highlighter? How do I do a highlighter here? This claim. They claim that the mean battery life, of course, that's not showing up very well, is 54 months. Okay, so let's write some HO and H1. So HO is always written so that it's an equal to. So do you see, and it's kind of blurry, but we should write HO, the mean, because this is about means, I'm going to use mu, is equal to 54 months. And I think that's the claim, because that's what the manufacturer is saying. Okay, so then H1 or HA, the alternative hypothesis, is now if this claim, now in my open math, you're going to see, if you've done my open math, you'll have seen some HOs where they say greater than or equal to. In this case, this would be a greater than equal to, because if those batteries last on average longer than 54 months, that satisfies the company's claim, right? So what we'll do here is we'll try to show that this is less than. It'll be a left-tailed test for H1. Now, the other reason I know it might be a left-tailed test is because that sample mean of 52 is less than 54. So I know it's going to be to the left of it. It'll be left-tailed test. It's something you can do. Sometimes you'll go with the wrong direction and you try to get the p-value or whatever, and you'll get something really whacked. So ask yourself, oh, what's the sample result showing? Okay, so we've done the claim, we stated the claim, we wrote the hypotheses, and identified which is the claim. Now we're going to run the actual test. Now, if this is a z-test, we're going to do a z-score. So let's do that here. Let me move this up. So z equals the mean. Let's see, the sample mean is 52. The population mean is 54, and the standard deviation for the sampling distribution is that population standard deviation divided by the square root of the sample size, which is, what's the sample size? 50. So that's going to give me -2 on top, and what is 6 divided by the square root of 50? So I'm just going to key that right into my calculator. 6 divided by the square root of 50. I'm getting 0.84. Since this isn't trying to make myopen math happy, we're just going to do it to 0.84, 0.85. And then 2 divided by 0.85, I'm getting a negative 2.35-ish. Now, if we think back to chapter 2 and we said, hey, if anything's more than, if it's a normal distribution and we get an outlier, if anything's more than 2 standard deviations below the mean is an outlier, we said, yeah, this would be an outlier because it says a sample of 50 batteries lasting only 52 months is well below the stated mean. So it's an outlier from what they're saying. Now, where's that critical value? Here it is. Here's the table from the bottom of Dr. Stevens' textbook table, and it's on page 288 because I see I cut off 289. So what we're going to look for is the common critical values of z-testing. So this is the critical value for the distribution. So we know that for z-scores, the mean is 0. We know if we go, let's see, we've got a 1% level of significance, does it say? They don't tell us anything. So here's the deal. Is somebody going to lose a lot of money if we make the wrong decision? Maybe. Maybe. So let's use alpha equals 0.01. So 0.01, it says it's the 0.01, and we're doing a left-tailed test. That lower cutoff is negative 2.33. And our test statistic is negative 2.53. Here, let me come back here with let me go with different ink. Here we go. So that's negative 2.535, which is out beyond it, barely out beyond it, but it is out beyond it. I mean, if we're just doing blind, looking at the test, we'd say, yep, we're gonna reject HO. It's close though, but it is out past it, so this consumer group could go back to the company and say, "Yep, I don't think you're telling the truth here," or that 54% or that 54-month claim isn't accurate, because it's very unlikely you get a sample of 50 and have a sample mean that low. Okay, so we've done everything here. Let me scroll back up and talk about what I've done, if I can scroll back up. Let's see. So I found the test statistic. I found a critical value of z. Now we just got to make a decision. I made a decision, reject HO, and now we got to write write that decision in the context of the claim. And this is where people, because of myopen math or because of myopen math and WebAssign, they don't always do this and they lose points on the exam. Because I want you to be able to understand what you're doing, not just do the calculation. I mean, because you don't have to do the calculation. You can go find a calculator and do it, right? Here, can I move this up? What am I going to do? Let's do this. I'll just go to a new page. So I had HO is the claim. I'm rejecting HO, right? So HO is the claim. I'm rejecting HO. I'm going to write that down. HO is the claim. I'm rejecting HO. So there's two ways to write a conclusion about this. One of them is to use Dr. Stevens' phrasing. So let's see. HO is the claim, right? HO is the claim. We rejected HO. And then how we start this, we say, there's enough. I guess I won't write all that, but this is how you want to write it. This is enough data to justify the rejection claim that, let's see, the mean battery life is at least 54 months. Okay, so I'm looking for all those pieces for this. Okay, and I hope that helps. I'm going to do a t-test next. So if you don't, if you want to go look at that, if you're stuck with it, you can do that too. Okay.